Today I'm going to reuse again the same exact example. That will be example 4.3 on page 123. But now it will be directly go into the discussion that we have on the terms, variability concept, and everything about the concept of ANOVA that you should know. Okay, so I'm going to start with the example. Okay, so this example will cover all about the assumption, basic concept and terms, randomizing experimental unit to factor level. But this one I'm not going to touch further because it will be very simple. And the one that will be very important is this one. Okay, this is the reason why we have ANOVA, and it is because of this. Okay, we know that we in hypothesis testing we would like to have evidence to support our claim. Okay, if we wish to reject the null hypothesis, and we need to show that our population means are different, so we wish to have sufficient evidence to reject the claim. So it will depend on this particular discussion on variability in response variable. Okay, so when we said about response variable, remember this response variable is what we call dependent variable. Okay, and this dependent variable is affected by our factor. Okay, our factor will affect the dependent variable because we know that the dependent variable is depending on the things that is being what we call imposed towards the experimental unit. So this is your result that you have or the outcome that you will collect at the end of your experiment. And this factor, we know that it will have different level. Okay, and that different level is what we call as treatment. Okay, so number 4, and this is what we call as treatment. Okay, and this factor is what we call independent variable. Okay, so now these are all the concepts that involve in the variability. Okay, and finally we will see how we can solve using Excel and then use the ANOVA table generated by Excel in order to perform our hypothesis testing and see how we can get the result, whether to reject or fail to reject. Okay, now we will go back to the example that we have in on page 123. Okay, I'm not going to read again about the questions because we have gone through the question a bit detail last time. But what we do need to understand is about the first one would be the assumptions of that particular population that we have in our discussion. Now we are talking about a car manufacturer and they are trying to find out for different brand of paint, that is brand A, B and C, what would be the drying time that this paint could give in terms of their result. Of course, if we are talking about the drying time, definitely we would like to shortcut our time so that it would save our cost for our manufacturing side. So we are looking forward to shorter drying time so that the process of completing the production of car would be much faster if we have shorter drying time. Okay, so what should we know about these three populations, brand A, brand B, and brand C? Okay, we know that there will be 4 assumptions that need to be fulfilled in order this particular ANOVA can be performed. Okay, so the first one would be there are 3 simple random samples of paint. Okay, if you look at the number of paints that we use, there will be 18 samples. And this sample, each brand will have 6 samples. Okay, 6 for each brand. But when we talk about the sample, we are talking about the population that we are selecting the sample from. So in this case, we are talking about 3 simple random sample of 10 paint brand A, B, and C drawn from 3 population of paints. And definitely, when we are talking about 3 population of paint, we are talking specifically a population A, population B, and population C from these three types of paint brand. Okay, that would be the first assumption. The second assumption is about the distribution of each of our sample data. And what we should know is that our data distribution of paint A, B, and C are all normally distributed. Okay, so you can imagine how the distribution of data A, data B, and data C. Okay, now the third one would be population of variances of pin A, B, and C are all equal. So if we draw again in terms of the distribution, okay, they will definitely have the same distribution. All are normal, and the spread of each of the population are similar. Then only ANOVA can be performed. And the fourth one would be there will be no effect of each pin towards each other. Means that samples of pin A, B, and C are independent of each other. Means that pin A won't affect pin B and pin B won't affect pin C. The same goes to A towards C. Okay, so that will be your assumption that need to be fulfilled before you can perform your hypothesis testing, or even do the experiment. Okay, you should have in mind that this assumption need to be ANOVA test. Now we are talking about the first exam questions that will be identify the response variable and factor in this problem. But I add the whole four terms and concept that you need to understand. Okay, so the response variable, okay, or what we call as the dependent variable, in this case would be the drying time, because all these values are representing the drying time for the three paints, and this is what we call dependent variable. Why dependent variable? Because the drying time is depending on which type of brand that we have, okay, which type of paint, of brand paint that we have in our experiment. Okay, so that's why we call it dependent variable. And what is our factor, or what we call as independent variable, means that brand A is not depending on the drying time. Okay, the brand is not depending on our drying time, but the drying time is depending on which brand that they are experimenting. Okay, so that's why we call it drying time as the dependent variable or response variable, and brand A, B, and C as the factor. The brand is the factor, and brand A, B, and C is what we call as our treatment. That will be the level of factors that we have in our experiment. And what would be the experimental unit? So since we are talking about car manufacturer, so we can imagine it's either the whole body car as the experimental unit, or some part of the car that will be included in the experiment. It could be the door, it could be the whatever part of the car that could be easier for them to do the experiment. Okay, all this must be known. You must understand how to figure out all these four keywords in the ANOVA test. Okay, so is the categorical variable, is the factor categorical variable? Why? Yes, if you look at the first page of your ANOVA, we have it mentioned somewhere that the factor must be will be in categorical form, because we have treatment level, and that treatment level will be based on the factor. So that's why we have the factor as the categorical, as this what we have now. Okay, why? Because the factor has three different brands. That would be A, B, and C, and definitely it shows that all these are categorical. Okay, so if you have any question, just stop me. Okay, I'm not going to go into detail because we have discussed this, so I would like to go so that everyone can understand, because the first model will make sure that you can understand the second model, that will be the factorial design. Okay, the next question is define the population parameter of interest in this study. So what will be your answer? The mean drying time for all paint will be the population parameter. So what would be the population defined as? So all pins reflect your population. Okay, so that will be your keyword for population, and we are looking at the drying time. Okay, so that's why the population parameter is the mean drying time for all pins, or the population mean of drying time. You can say that way. Okay, population mean of drying time. That will be also can. Okay. Now, what is the purpose of this study? To evaluate the cause and effect relationship between three different pins. That will be A, B, and C, and its drying time. Because what is the effect? Is the drying time. What is the cause? Different pin type. So you need to understand the concept of cause and effect relationship. Okay, so that's how the ANOVA, one-way ANOVA is all about. And next, suggest suitable statistical test for the problem in 4. Support your reason. Okay, so easily we can say one-way ANOVA, testing the equality of population means. Okay, so you can just stop at this, or you can say this also can. Why? Because it involves 3 populations. So that would be your easiest reason to form ANOVA 1 week. Okay, so that would be number 5, sorry. And finally, this is the one that I need to go into detail since we have not discussed this in the last class. Okay, conduct the suggested test in 5 at alpha 0.05. Okay, as we know that we have 5 steps. Okay, step H0 and H1. Second step, find the critical value, almost similar in what we have in chapter 3, performing hypothesis testing, and we have 5 steps. The third step will be calculating the test statistic. So since in ANOVA, since we are talking about what we call more than 3 population, so we are using F-test. Okay, so F-test is specifically for greater or equal to 3 population. That's why we use F-test, and we know the distribution of our F-test is somewhat like skewed to the right. Okay, and it begins at 0. Okay, so that would be your F-test or F distribution. Sorry. And how do I find my F critical value? Critical value will always relate to your alpha. So your F critical value would be defined by your alpha as your first parameter. Your second parameter is K minus 1. That would be the number of population that we have. And the third one is the number of sample minus the number of population that we have in our experiment. That will be F critical value. We will see later how we can find using the F table. Okay, and number 3, test statistic. In our case, it will be F test. And our F test is obtained by mean square treatment divided by mean square error. So what is this? We will look afterwards. And number 4, making revision. And as usual, if we have our alpha here, okay, so this is our alpha. Definitely this will be your F alpha, K minus 1 and minus K. And this is our rejection region. And if our F test falls in the non-rejection region, then we reject. If it is fall within the rejection region, then we reject. So here you reject, here you fail to reject. And the condition as mentioned here. Okay, so that's how the whole thing about the F test looks like. And finally, we make conclusion whether we have sufficient or insufficient evidence to reject the claim. Okay, so that will be in short how we can perform the ANOVA, one-way ANOVA. Okay, now how can we make it simpler if we are using our Excel? Okay, so what would be our step 1? What would be our statement of hypothesis? Okay, since we are talking about the drying time, okay, what would be our statement? So our statement will be the now there is no difference in the mean drying time between the three paints. And the alternative would be at least one population mean drying time is not equal from the others. And for step number 2, step number 3, we are going to generate using Excel. Let me show you, okay, in theory, how it begins. Okay, we will start by what we call install our data in Excel. Okay, it's either you are using your data using column wise. So this is, for example, a column wise. Means that your population will be located in one column. Second, in the second column. Third, population in the third column. That will be your first step. Then go to data, and in your data, there will be data analysis. So click data analysis, and this pop-up will come up. Data analysis pop-up, and you are going to select in your option ANOVA single factor. Why single factor? Because we have one, we have one factor that will be paint brand. Okay, even though we have 3 treatment level, but the factor is considered as one, we have paint brand as our factor. So then you will click OK, and I will show you how to use your Excel afterwards. That will be case for data if your data is in column wise. What if your data in what we call row wise? Okay, so it will be almost similar, but then in the box that will be what we call click later on, it will be a bit different on how we define the location of our data. So that's how our what we call the way how we can use our Excel. Very simple and easy actually. Okay, and before we start with our Excel, so this is how your ANOVA table is being generated, and what are inside your table are this one. So your first line would be your what we call information that you will have in your ANOVA table. So your first column would be source of variation, and we know that our source of variation come from between the group that will be coming from our treatment, and it will also coming from within the group variation, that and also known as our error. And adding these two, we will get our total error or total variation. And the second column is what we call the sum of square. Okay, so if let's say you see somewhere you see SSTR, what it meant is it is sum of square treatment. TR stands for treatment. Okay, what is treatment? Brand A, brand B, brand C. Okay, what about error? And it is coming from within. So this is your error, sum of square error. Sum of square error. And this is coming from within group variation. Okay, so last time I have discussed these terms in detail within group variation. Somehow we are going to see it in terms of this particular problem. And of course, the total sum of square total. And for the degree of freedom, so this is the one that we use in our FCB. Okay, remember our FCB is F alpha, K minus 1, N minus K. This is coming from the treatment. Okay, and this is coming from the from our error. Okay, always treatment first and then second, followed by error. Don't error and then treatment, then everything will upside down. Okay, so that would be wrong. And then your degree of freedom for the total will always be the whole number of sample minus 1. And then what is about the mean square? Okay, so we have mean square error obtained by SSTR divided by the degree of freedom. The same goes to mean square error, mean square treatment is SSTR divided K minus 1, mean square error SSE divided N minus K. And our F test is the one that we need to use to make decision, is obtained by dividing the mean square treatment divided by mean square error. Okay, so this is how we get the F test, and we are going to compare both of these. Now, let us begin with the ANOVA using Excel. Okay, let me bring you with the cell. Okay, can you see my transition of slide here, class? Class? Can you see my Excel now?
Yes, madam.
Yes, madam.
Okay, okay, thank you. Okay, let me bring you the, okay. Now, we have our example. Now, is it too small? Can you see clearly, or is it, do you want me to enlarge?
Very clear. Okay, madam.
Okay, thank you. Now, let's say we do both. Okay, what if our data is column-wise and row-wise? Okay, so we will see how we can do if it is in column-wise and row-wise. Okay, so let's say we use our column-wise first. What you need to do is to make sure in your data you have this. Okay, if you don't have data analysis here, what you need to do, go to file, go to option, and then make sure you go to add in. Okay, and then in add in, please add analysis to effect here. Okay, and then click go, and then click OK. Okay, then everything will be inside your data analysis. Okay, let me okay, let us begin with the analysis. So I have the result here, but I want to redo again. Okay, go to data analysis. Okay, then you will have this data analysis pop up. Go to ANOVA single factor, click OK. Then you will have this table. Now, what is this? Okay, you have your input range. Okay, click in the at the red arrow, and then you have this. Go to your data, include the data, the brand name. Okay, highlight until everything is inside. Check. Okay, everything from B1 until B7. Then click again here. Fine. Now I have in column wise. So click column. Don't click row, because if it is row, then everything is wrong. Okay, click column. Okay, and then I have my column name in the first row. Okay, so click in the first row. Then I have my alpha. Since we are using 0.05, then put 0.05. If in your operation you need to use your 0.10, then change it into 0.10. So since we are using 0.05, then write 0.05, and then make sure, in my case, I would like to have my data, what we call result side by side with my data. So I just put somewhere. Okay, let's say I put it here. Okay, and then click again, and then click OK. Okay, so you will have your result of your ANOVA. So if you are talking about on face-to-face learning, all this need to be calculated manually. So since we have online learning, so everything need to be simplified. So we decided to use what we call Excel to help us out. Okay, so that will be in your result of ANOVA. So let's say I erase this since I have my result here. So what do you have in your result? First, in summary, okay, for column A, for row brand A, okay, you have count, means that you have 6 data, and then you have sum. Sum means that you have add all this value, and then you get this summation, and then the average is the summation divided by the number of sample for each brand, and then you have your X bar that will be 76.17. The same goes to brand B, brand C. And then you also have your variance for each brand A, B, and C. Okay, so that's how you can have your summary table and what are the information given in your summary table. But what more important is your ANOVA table. That is this one. Okay, this is the one that you need to use in order to make decision whether you will reject or will to reject. Okay, so this will be the table. So let me bring you back to the slide that I have shared just now, since I have saved them for you. Okay, so let us start with the, okay, so I have discussed this. Now, what is this? This is your SSTR. What is this? This is your SSE. Okay, and this is your SS total. Okay, and this is your degree of freedom for K minus 1. We have 3K, 3 minus 1, we have 2. And then this is N minus K, and this is N minus 1. Okay, class, why I keep repeating this? Because once you, now it seems everything very simple, but once you need to do it on your own, that's how you will, you need to remember back everything in specific. Okay, so how do I get this one? This one is 2482 divided by 2, and this one is 774 divided by 50. Dividing MSTR by MSE, I will get this. And this will be my critical value. So that will be F alpha 0.05 to 15 is given by 3.68. That will be generated by Excel. What if you are using your table? So let us see. 0.05 to 15. Why don't we look at our table? For alpha 0.05, okay, look for your table of F at the back of your textbook. So you will have your alpha 0.05. Okay, so here 0.05, and then the other one is 0.01. So please make sure that you are referring to the correct alpha to refer to. Now let's say we know that we have F 0.05 to 50. So where do I look? Okay, so you see you have your parameter alpha, V1 and V2. So V1 refer to this one. Okay, and V2 refers to N minus K. Okay, so V1 to V2 15. Okay, V2 15. So you will have 3.682. So similar to your table of ANOVA given by Excel. Okay, so how do we make decision? Okay, I think I have discussed this later. Okay, I will going to make decision later on when we come to the point that I have suggested for your class. Okay, so this is your F test. So this is your F test, and this is your F critical value, and you are also given the P value. Okay, so P value is obtained by using F test. Okay, by using your F test, you will get your P value. If I rewrite again the distribution, okay, so let's say this is your alpha. So my F alpha will be here. So let's say I write directly using our discussion. So F 0.05 to 15. So this is what? 3.68. 3.68. Okay, so 24 is further away from 3.68. Let's see here. So F test is equal to 24.05. So what is my P value? My P value is given by this one. So this is my P value. This is P value. And this is our alpha. Okay, so this is our alpha. So the alpha will include the P value. So you can imagine the probability value, which is very small compared to your alpha, 0.05, which is this one is 0.000 something. Okay, so that's how you interpret your ANOVA table. So far, class, at this stage, do you have any problem or do you have any questions, class? Class?
No
Do you have any?
question.
Okay, okay. Okay, yeah. Now, how does the whole thing about variability comes in? Okay, last time we have discussed about within group variation, between group variation, total variation. So in this case, class, I always tell my students to see the first hint from their summary table. For example, this one, class. Okay, let us look at the summation of all the brand A, B, and C, and look at the average for each of the brand. Okay, what can you see from this particular box in red, class? What can you see here? Can someone please throw your idea from this particular red box here? What can you say from brand A, B, and C in terms of the drying time? Class, what can you say? Class? Anybody who wants to try, please? Why don't you give your idea or your thought? Okay? Hello? Obviously, you can see 76, 53, 49. What can you say from these values? Class? Hello? Are all with me? Are all still with me? Hello?
Yes, madam.
Okay. Can someone please just tell me what do you think about these all three values? We are talking about drying time, right? Drying time for brand A, brand B, brand C. What can you say from this all sample mean?
Each brand has a different drying time.
Yeah, we believe that from the values here, from the summary values, we may assume that the mean drying time for all brand A, B, and C are different. Okay, that would be the first one. What about second one? What can you say about the mean drying time of the three brands? Other than we assume there will be difference. The mean drying time are different. What else can you observe from the data, summary data?
Brand A has highest drying time.
Brand C, yes, correct. Brand C has shortest drying time. That would be very good observation. Class, in ANOVA, performing ANOVA require your meticulous what we call observation. So this will be among the first observation that you need to understand from your data. Okay, so I think this will be the obvious thing. Okay, so now when we have this particular thought, class, what we have in mind is that if I perform ANOVA test, ANOVA, one-way ANOVA, most probably I will reject the null hypothesis. That will be your first assumption. I may reject my null statement and says that it will be different from each other. But that will not be proven until you do the what we call test. Okay. Now, what about the within group variation and between group variation. Now remember, within group variation is calculated based on the variability among observation in the corresponding group. So that's why I put here. So this is within group variation. And between group variation is based on the sample mean. Okay, sample mean for the group 1 with the grand mean. Sample mean for group 2 with the grand mean. Sample mean for group 3 with the grand mean. So the grand mean, how do I get my grand mean? You can add all this. Okay, grand mean equal to 457 plus 321 plus 297 divided by 80. So you will get your mean. That will be 59.7. Okay, so you can see from this particular graph, you can see that among these, C may give shortest drying time, but we cannot see it until we prove that using our hypothesis testing. Okay, so that will be the whole thing about variation. Okay, now in terms of calculation, now I need to show you this is in terms of what we call theoretical part. But how in terms of calculation, and how does this being done? Rather than, you know, just looking at the ANOVA table and everything is being calculated for you, but how in reality these things are all calculated. Okay, just to give you an idea. So the between group variation, remember class, it's within the group. Okay, that's why we take the mean of each group. Okay, the mean of each group minus the grand mean. So this is the grand mean. So this is like x bar A, this is x bar B, and this is x bar C. Okay, so and this is how it represented in terms of calculation statistically. Okay, so you can see the SSPR is 2481.79 as what we have in our ANOVA table. And how do we get our SSE? Usually SSE is obtained by SST minus by SSPR. So means that you need to find your total variation. And your total variation is based on your each data value. Okay, take all your data, square them, add them all, minus the grand mean. Okay, the grand mean. So if you can see here, these are all data. These are all data. So this data from brand C and this data from brand A. So you have all the brand A, B, and C included inside your calculation. That's how we call it total variation. Okay, as a representation of what we have in our theoretical just now. Okay, as this one. Now, let us continue with the result just now. Okay, because this is our first discussion, I need to go into detail so that everyone can understand. So for the second model, I will just go straight to the point to our discussion. Okay, so I have already given you in terms of the what we call the short form of each of the data that you have in your ANOVA table. Okay, so please understand, if you don't need to remember, but at least you need to understand how these are being obtained. Okay, now let us look at our solution, how we can solve these equations. Okay, we have discussed our null and alternative statement just now, and from our ANOVA table, we know that our FCV is 3.68 and our F test is obtained by 24.05. Now, for the decision making, you can either use your alpha and your P. The same goes to your F test and FCV. So, how do we make decision then? Okay, so in this case, if you are using your alpha and P, remember just now we have this particular. Okay, we have this. This is your alpha. And then this is your F test, FCV. and you will have your F test. Okay, you will have your F test. Okay, somewhere over here, F test. Now, you know that your F test is 24.05 and then your FCV is 3.68 and definitely falls in the rejection region. Then we reject the null hypothesis. Or if you wish to compare using your alpha and p, since alpha is greater than p value, okay, then we reject the null hypothesis. Okay, so make sure theoretically all these steps you need to understand, because during the assessment, since we have online assessment, so everything would be in terms of understanding. So if you don't understand, it will be difficult for you to find the answer. Okay, now for the conclusion, how do we conclude then? Okay, the question just now, how do we know that which one it will be our claim? So let us look back at our question. Now, 18, assume, okay, a manufacturer would like to compare the drying time for 3 different brands. So doesn't mention about the claim. So let's just answer the question, okay, without knowing which one is your claim. Okay, so since we reject the null hypothesis, remember, reject null means that, remember when we discussed chapter 3, I have given you the summary. Okay, if you reject null, means that you have sufficient evidence. Sufficient evidence for what? Sufficient evidence to reject. Okay, to reject. So that would be to reject. So in this case, because okay, in this case, I need to erase again since I directly take from your this class from your textbook. If I'm not mistaken, this is how your textbook is being used to discuss about the conclusion. Okay, there is sufficient evidence to support the claim that the mean drying time between the 3 brands of paint are significantly different. So in this case, it seems like the claim is somewhere at the now alternative statement. So as if this is your claim, because you are talking about supporting your claim. Okay, so we have sufficient evidence to support the claim that the mean drying time between the 3 brands of paint are significantly different at alpha 0.05. So that's how about our first example. Okay, so do you have any questions so far, class? Do you have any questions so far, class?
No question.
Okay, thank you. Now, my question to you would be, how do I know since we have the decision and we know that the mean drying time of the 3 brands are significantly different? My question then, do we know which of the mean drying time are different? Plus, do we know which mean drying time are different? Which drying time of paint are different? Do you know, class? Yes or no? Yes or no, class? Hello? Class?
Yes, madam.
Which drying time of paint are different? Do we know?
Yes, yes.
Do we know, class?
Yes, yes.
How do we know then? How do we know? Do we know which one is different? Which one is similar? Yes or no? My goodness. If I were to wait you, I don't know at what time you are going to answer my question. Which drying time are different? Do we know? The answer is no. Okay. Ikutkan hati nak stop sharing, nak pergi dekat online, dekat gini nak semua suruh turn on video supaya saya nampak muka semua tapi tak nak ikutkan hati lah, tak apalah, saya teruskan juga. Now the answer would be we don't know which of the drying time, the mean drying time of the brand paint would be different because as we know ANOVA, okay, ANOVA make decision simultaneously. Simultaneously test for equality. So it will not give you the answer of which of the brand that are different. Okay, so that's why, okay, my discussion, this one followed. Okay, there is sufficient evidence to support the claim that the mean drying time of the three brands of paint are significantly different. But ANOVA does not tell us which of the pair of the population means that are different. So what do we mean by this? So this is what I meant. Okay, which pair are different? Is it brand A and brand B? We don't know. Is it brand A and brand C? We don't know. Is it brand B and brand C? Also, we don't know. Or is it all the three are different? We also do not know. But what do we need to do if we wish to find out which of the pair that is different? Then we need to perform our post-hoc test. Okay, you need to perform our post-hoc test. And if you go back to your chapter 3, okay, chapter 3, in chapter 3, we are talking about hypothesis testing for two populations. And what do we use in two population class to do the hypothesis test? It's either using your t-test or z-test, right? So this is what you need to do. Okay, so you will go back to your two sample or two population hypothesis testing, and you need to look at how does this will be done. So I'm not going to do for this one, but I want you to understand from this particular what we call conclusion, and how we need to know which of the population means that are different if we reject the null hypothesis. Okay, class, do you have any question here? Do you have any question for this discussion, class?
No, doctor.
Okay, thank you. Last but not least, okay, my comment would be on this one. Okay, this one. Okay, if you read out, remember the larger the MSTR, the higher the F-test, the higher the chance to reject the null hypothesis. So ANOVA class, for ANOVA, question relating to ANOVA, more concept will be asked because we will have less in terms of calculation. Of course, there will be part that you will need to calculate, but most of the time it will go back to the concept, and you need to understand the whole concept about ANOVA, regardless we are talking about one-way ANOVA or two-way ANOVA with application. So you need to understand each and every single concept involved in this particular chapter. Now, what do we mean by the larger the MSTR? Where is MSTR? MSTR is coming from our SSTR. Where is our SSTR? Our SSTR is obtained from between group variation. That will be here, SSTR. And we have our okay. We have our SSTR here, we have our SSE here, and we have our SST here. Now, when we are talking about SSTR, okay, then we know that we will have our MSTR here. MSTR. Okay, means that if this is larger, okay, because why? F test is obtained by MSTR divided by MST. So if you have larger value here, smaller value here, what is your value of F test? You will have larger value. If you have MSTR and MSE over MSE, lower MSTR, higher MSE, what happens? You will have very small F test. So if you have small F test, what happens, class? What does it affect in terms of the distribution even we need to make decision? Remember, you are going to have your F test, okay, and your FCV will always bound your rejection region, FCV, F alpha here. N minus K, K minus, sorry, N, K minus, K minus 1, N minus K. And this is your rejection region. Now, if your MSTR is larger, your MSE is smaller. So if you have larger MSTR, what happens? You will have larger of F test. If you have smaller MSTR, larger MSE, definitely if your denominator is larger, so you will have smaller F test. So what happens? Your F test will tend to approaching 0. Okay, so this is where your F test lies. So we don't want this because we want to show that there is a difference. So we always wish to have this particular position. Okay, so please remember of this particular part. And of course, it will reflect your treatment error and within group variation error. So this is between group and opposed to within group variation. Okay, so that's how we need to understand how does your decision can be affected. Okay, so that will be in terms of F test. What about F alpha? What about the alpha value? So you need to understand if your alpha is 0.05 compared to your alpha is 0.01. So look at your value of your F alpha. Okay, so it will definitely give you different F critical value. So far, do you have any question at this page, class? Do you have any question?
No.